Right, I gather for many of you that these are the 5 parts that you face most problems. So I'm going to go through only these 5 parts to tutorial 11.2. All right. So quickly, now I said it before. Differentiation is almost like you have a toolbox. Search through your tools in your mind. As you get more practice, the searching of the tools gets faster and faster. So in this question, we probably think, okay, f prime x over fx, right? You are thinking your thought process is f prime x over fx. But if this is fx, f prime x is going to look slightly complicated, right? You can try, but you realize it's a little bit complicated. It doesn't look like what is in the numerator. So maybe not. It is very much try and error. I already want to tell you, sometimes I also need to try, but don't try too long. You with practice, your trying will be faster and faster. So a trick here is if you have a plus in your numerator and denominator, what you could do is to split up the numerator and denominator like that. It is still not obvious how you're going to carry on here, but let me explain. This is easy now. Your ln x over ln x is 1. You realize that 2 over x is easy to integrate. What happens to here? It takes a little trick here. If it's fx, this is no way in the world this is going to be f prime x, your numerator. But if you rearrange it like that, then it becomes f prime x over fx. Then it is a lot easier. It will become ln mod ln x plus 2 ln mod x plus c. I want to emphasize this. Alright, I want to emphasize this must be mod. Whenever you get a ln mod, you must always have a mod sign by default. Alright. In some cases, let me give you an example. If it is ln 1 plus x squared, why the ink like that? Okay, let me edit this. Pencil. Sorry. Never mind. I think I know. Sorry for the delay. If the answer is ln 1 plus x squared with a mod, you would simplify it to a 1 plus x squared with a bracket. You must simplify. Why? Because there's 1 plus x squared is always positive. So you start off here first, then you write this. Then whenever you have any expression with a ln, you start with mod first, then question yourself, is the expression in the mod always positive? For example, this one. If you cannot get an answer very, very quickly, you don't know, leave it as it is. If not sure. That means leave it as it is means with mod sign. With mod sign. However, for this question or for any question, you always ask yourself, is it always positive? In this question, I would tell you, you would leave it as 2 ln x if you want to be super precise. Why? Because the phrasing of the question over here would have suggested x would have been positive. Otherwise, the question wouldn't be able to run. Follow what I'm saying? Yes? So x is always positive. Here, hence it's like that. Now, if you have left it as this, a lenient marker would have gave you full credit. I'm not saying you always get full credit here, but sometimes. It is definitely better. This is definitely better than leaving this thing without mod. Then it's wrong already. This one is just not precise. This is precise. But if you leave it as bracket, that means what you're saying. I'm saying is if you leave it as bracket, then this is wrong. Okay, I'll move on. 4B. Sorry, 4C. Now, 4C is special in that if it's sine square, then okay, you know how to do. But sine cube, is there any identity, anything that can help me? Unfortunately, not really. So I can understand why it's difficult for you, but let us try. Desperate now. Let's do this. You say, okay. Then when you see like that, you may suspect. The word is suspect. This kind. Correct? F prime x, fx to the power n. So fx to the power n plus 1 over n plus 1. But not quite, because if your fx is sine x, your f prime x is cosine. But this is a sine. Then a trick would be this. Right? Then they say, I'm still not very sure. Let's see. Look, now you can look at this one here. In fact, with the minus sign, it's even better. Because if fx is cosine x, f prime x is minus sine x. So, answer is out. I will write it like that for clarity. All right, the last line is obvious. Therefore, it is a minus cosine x plus 1/3 cosine cube x plus c. Okay, play it again if you are not sure. All right, done. 40. Again, you ask, run through your mind, f prime is fx, whatever, standard form. No, there's no standard form for square root 1 over for this kind of thing. So writing nothing will give you 0. Writing some rubbish, you may get half mark, 1 mark, whatever. So I think all of you should have it in you to be able to expand to get here. Correct? Expansion is not difficult. Once you expand, you're done. So again, I want to emphasize it must be mod. Again, I want to say you then have to ask yourself, can you remove the mod? The answer is yes, because by looking at the question, it is inherently implied that x is positive. Now, because x is positive, at least non-negative. All right. Actually, it should be, or rather, it should be positive. Sorry. All right. Otherwise, it won't be different. Now, it is not wrong to leave here, but it's more precise to leave here. If you cannot see from here to here, it is not the end of the world. Okay, unclear? Rewind. E. Let's take a look at E. Now, this is special. Remember in my revision, in my summary, I talked about linear over quadratic. Correct? If it's linear over quadratic, what do? You will express it such that you have f prime x over fx. Okay, think f prime x over fx. Now, for E is a similar idea, but not identical. All right. If I may refer you to question 3, 3A. All right, you see question 3A. So question 3A would have been reduced to linear over quadratic. Now this is not quite linear over quadratic. It's a linear divided by a square root of a quadratic. Trickier, definitely trickier, but the concept is somewhat related. What do I mean? Now I give you an example. If I ask you to integrate, say, 2x over square root x squared plus 1, do you know how to integrate? Five, 4, 3, 2, 1. You should know how to integrate because this is of the form f prime x fx to the power of n. Again, f prime x fx to the power of n. So this will provide some clue in how to deal with this. All right. So if I have a form f prime x here in your numerator, then my battle is half won. All right, my battle is half won. So how do we do it? I make it appear. It is minus 2x plus 2. That is my minus 2x plus 2 is my f prime x, but I cannot say they are equal, right? What helps? I put a half. Why? Because half times minus 2x, I get minus x. Half times 2, I get 1, but I'm short of a 2 because it's a 3, so plus 2. So far so good. So, next. I get a half, integrate, minus 2x plus 2, plus integrate 2 over, I'm going to complete the square for the denominator now, all right, which is a 4 minus x minus 1 squared. Now you go and verify whether I complete square correctly, but from here to here, I just complete square. All right. In fact, I want to make it a little bit simpler. My 2, I want to bring out. I want to put my 2 here. This is a f prime x fx to the power of minus half. This is not f prime x over fx. I want to emphasize. Maybe you want to write it down. This is not f prime x over fx. Oh, this is not f prime x. This is f prime x fx to the power minus half. So this is actually half. 3 minus x squared plus 2x to the power of half over half plus 2. Now, this is a squared minus x squared. Look here, a squared minus x. A squared, sorry. A squared minus x squared here. Square root, this one. A squared minus x squared. Sine inverse x over a. So therefore, it is sine inverse x over a plus c. This half goes. Final answer, that is your question for E. The toughest so a part of this tutorial is definitely H. So I'll go down to H now. Let's see. Again, writing nothing, 0, writing something will surely give you a chance of getting some marks. There is also a reason why they give you this M and N are belong to integer. Okay. Now write something. Surely you can expand. Right? Surely you can expand. So let's expand. Right? Now recall, always think. Now, what if your thought process, your bubble, what if M is 2, N is 5? How would you do this? I'm not saying you substitute 2 and 5 to solve it. I'm saying that you think, how are you going to do it if M is 2, N is 5? Is it that bad? If you see a sine square, you have to recall cosine 2a is 1 minus 2 sine square a. Correct? Which means you will use double angle formula to get this. Half 1 minus cosine 2mx. Correct? You rearrange this, you will get sine square a equals to half 1 minus cosine 2a. The line above is a formula list, the line below is just rearranged. So you can do this. Similarly, you can get a half 1 minus cosine 2nx. Then what happens to this 2 sine mx sine nx? This is a product. You have to recall factor formula. Factor formula. Factor formula, a particular line in your factor formula says this. Cosine p plus cosine q, correct, equals to 2 sine p plus q over 2 sine p minus q over 2. So if this is sine times sine, this is sine times sine, p is actually this plus this, or this plus this, correct? Q is actually this minus this. So I'll get a, sorry, I beg your pardon, there's a negative sign missing. So therefore it's a minus away. Cosine mx plus nx plus cosine mx minus nx. At this point, I have not done integration, by the way. All right, I have not done integration. Let me enclose it in a big bracket. Okay, so I'm applying here, this one. I'm applying factor formula here. This is from formula list. I didn't do anything. Or I've said it before. I will not say it again because I've said it in tutorial 11.1. This one is actually this plus this. All right, so therefore it's mx plus nx, mx minus n. So far so good. So now we can try and integrate. It's not difficult to integrate. Why? Because nothing. Do I know how to integrate? If again m is 2, do I know how to integrate? I know. So here to here is integration already. So let's do this integration. There's a half here. There's a half here. Combine to 1. Integrate 1, you get x. No problem. Integrate cosine, you get sine. Correct? You have a minus. sine 2mx. But not quite correct, all right, because you have a mx, so you must divide by 2m. And there's a 2 here, divide by 4m. Check. When I differentiate this, do I get back this? Yes. Don't believe you tried. Minus sine 2nx. This expression is exactly the same except they change m to n. Right? Integrate cosine. This, if I were to rewrite, it is actually m plus n times x, right? The coefficient of x is m plus n. Yeah. So can we, if I integrate cosine, I get sine. Therefore, it's a minus sine m plus n x divided by m plus n. Similarly, I have a sine m minus n x divided by m minus n. You may think like that very complicated. Sure, if you stop here, I won't blame you. If you stop here, I won't blame you. Why? Because let's see, you don't know how to do. But if m and n are integers, let me highlight here. M and n are integers. If m and n are integers, 2m also integer. In fact, even m. Think, what is sine 6 pi? Because you substitute pi here. Sine 6 pi, sine 8 pi, sine 10 pi, 12 pi are all 0. This one also 0. This one also 0. This one also 0. So you're left with a pi. You sub 0 in, sine 0 is always 0, 0, 0. Actually, the answer is just pi. Done. Alright, stop here. If you are not sure, you rewind. Thank you.